Hi, good afternoon. This is Justin Pineda, and for today, we're going to discuss Module 1, General Security Concepts. So we start with the definition. What is information security? Because there's common misconception that information security is cybersecurity, and it's the same with IT security, and so on. So let's try to define what information security is. So, comparing information security versus IT security. Um, First, information security has many domains. So, according to ISC squared, the organization that handles the Certified Information System Security Professional Certification, okay, it has a lot of domains. So, it may range from technical to non-technical domains such as access control, telecommunications and network security, information security governance and risk management, software development security, cryptography, security architecture and design, operation security, business continuity, and disaster recovery planning, legal, regulations, investigations, and compliance, physical, or in other books called environmental security. So if you will notice, it has so many domains. Whereas compared to IT security, it only focuses on software and hardware technologies such as antivirus, firewall, um, and other controls in the IT. Okay, so that's why it's very broad. It's important also to know the contributions of other domains to secure the information. Okay. So, according to Isaac and Isaac, okay, we can also define information security through these terms, and these terms are used um, always in determining the security issue, determining the um, security controls that will be implemented. Okay, so the first one is confidentiality, the second is integrity, and the third is availability. So for confidentiality, it is the protection from unauthorized disclosure. The second is integrity, protection of resources from modification. And the third one is availability, which is protection from denial of service. So it's important that in any type of security domain, we need to be able to identify among the three the security issue at hand. So for example, if let's go to some of the examples. So let's have some examples. A stranger is able to enter the campus premises by using a fake ID and impersonate as an employee. So you are able to impersonate unauthorized access. So that would fall under confidentiality. So that's a confidentiality issue, right? The school servers are down because there's a blackout and there's no generator. That will fall under availability because there is a denial of service. So these are some of the examples of confidentiality, integrity, and availability. Okay. Now let's go to security architecture. In defining security architecture, it says that in order for you to have a secure data, you need to have multiple layers of defense. And that would mean not relying on just a single type. Okay. So, for example, in this scenario, we start with in the outermost layer, okay, um, physical security, okay, which talks about the gates, the locks, the CCTVs, and going to operational security, which talks about administrative um, controls such as policies, going to network securities like firewalls, intrusion detection systems, going to host security, which can be for servers, it can be a host IDS or a WAF for web servers, or an antivirus for the endpoints, and then application security, we can use encryption before going to the data. So that is how the security architecture works. And multiple layers of defense are implemented to secure the data. Now let's go to security service and mechanisms. So when we say security service, this is how objectives are manifested. And when we say security mechanisms, is the solutions that we can implement in the enterprise. So during business cases, strategic planning, or or brainstorming in the IT security department, you need to be able to identify the security service and mechanisms that you would like to implement for the organization. Okay, and we'll have an example in the next slide. But here are some of the inconvenient truths. Number one, you cannot protect everything from everyone, and that's the reality. Okay, and this is what the problem is. The primary problem is for most IT security teams because they want to resolve all types of security issues when in fact they cannot do that. Okay, cannot protect everything from everyone because there are so many risks out there. Okay? And the second inconvenient truth is there are not enough resources and money in the world to totally mitigate all risks. Okay? Especially because for a lot of industries, IT is considered a cost center. Therefore, um, most of the things that we want for the organization would be considered cost in the eyes of the management. So it's hard to defend procuring very expensive tools. Okay? And that's why for number three, so the technique is to focus on protecting the most important information first, that which must be protected and that with the highest risk. So because there are so many risks, we cannot protect all of them. We need to choose the one with the highest risk and then provide protection. And this is followed by organizations with a solid or mature IT security department. So, for example, the goal is I want to focus on physical security. That is the goal. So, for the security services, so the services would be on personal security and in access control. Okay, so these are the security services. For the security mechanisms, I will be implementing security clearance. Okay. I will be implementing training and rules of behavior. And then I will be deploying number two, biometrics, proximity card, and man trap. So because they are focused on physical physical security. Okay. So what industry do you think would be implementing this type of service and mechanism example? So probably it would be a bank or um, a military office, right? Because these are the characteristics of their security. But you wouldn't expect this in a school. So that's why it's important to determine or to enumerate the security services and mechanisms during planning. Now, let's go to operational model of security. So, for many years, the focus was on prevention because during the early 90s, um, there were less attacks directly targeting consumers. So, years ago, the formula for protection is prevention. Meaning to say, if you would like to protect something, you have to prevent it from happening. For example, the use of firewalls. Okay, so a firewall by default is a preventive tool. So it will only allow certain ports or certain services, certain IPs going in and out of the network. So if you're not in the list, you're not allowed to go in. So traffic is prevented from going in. Okay. Now the problem there is that as time progressed, attacks became more sophisticated, and that certain attacks on specific targets, okay, um, became more advanced. Like um, you launch a denial of service or distributed denial of service on port 80, okay, which is a web traffic. I launch so many packets on port 80, and we know that port 80 is allowed by default in the firewall. So the the firewall will allow the traffic, and then the attack will still be successful. So that's an example of the limitations of prevention. Okay? Um, that's why the formula for protection was modified and included detection and response. So protection is equal to prevention plus detection plus response. This means we are conceding that not all attacks can be prevented, but there are mechanisms that can detect it and then respond later on so that the issue will be remediated. Okay. So some other security principles: host security, protecting the individual device. Okay. Whereas network security, emphasis is placed on controlling access to internal computer from external entities. Usually we call it sensors because it can detect the traffic of X number of workstations or end devices. Some other security principles include um, least privilege. Right? We call it the cornerstone of information security because regardless of the type of um, domain or security layer, okay, the best implementation of security is least privilege. Okay? So it's defined as an object should only have the rights and privileges necessary to perform its task with no additional permissions. So this means if you're coming from finance, if you're working in finance, I will just ask what specific applications do you need? You need calculator, you need MS Word, you need Outlook. That's all. You don't need internet, or you probably need internet, but you only need a specific website. So that these are the only things that will be allowed. The rest it will not be allowed. So no Spotify, no YouTube, no Facebook. Okay. So in essence, ideally that's a best case scenario for security because I'm only giving what you need. Okay. But in the real world, um, it's hard to implement because people are not robots. Okay. So some employees will need breaks and will have to use Facebook, etc. So that's why in some organizations they try to balance it out. Okay. And this is the reason why information security or IT security teams are the enemies of the normal employees or of the other employees. Um, Now, some of the case of user privilege, like for example, comparing Linux and um, Microsoft, we know that in Linux, even if you are the owner of the system, by default, you are a regular user. Right? You only use sudo to elevate the privilege when you need higher level access of higher level of access or permission. Like for example, you're going to install something. Okay, so Linux will allow you to go sudo um, higher privilege and then go back to the regular as a regular user afterwards. Okay, whereas comparing it with Microsoft, by default you are an admin, right? So these are two different, totally different operating systems, and their approach to security is also different. Right? So types of least privilege. So here are some. So we have separation of duties, where for a given task, more than one person should be involved, okay, which is normal for big organizations. Okay. But for relatively small organizations, this is hard to implement because you need additional resource just to do that particular role. The second is implicit deny, wherein it says if there is no rule that says give access, then access should not be granted. And number three is job rotation, which means we are not relying on one individual too heavily on a security expertise. So what is an example of separation of duties? So you're the employee in this scenario. So what will happen if your manager and the HR and the finance are one and the same person? So the HR, manager, finance, they are one and the same. Okay, so there will be a problem because there might be conflict of interest. Okay, so because if the manager is angry at you, since he's the HR, he might not process your salary, might not give you the salary for finance. Or if you are friends with him, then even if you did not go to work, you will still get your salary because the person is one and the same. Right. So that is the concept of separation of duties. There has to be a separate person for each of these critical roles to check the other. Okay. Now let's go to types of access control. We have four types: mandatory access control, discretionary, role-based, and rule-based access control. So let's start with mandatory access control. So for mandatory access control, so it's restricting access to the subject based on sensitivity or need to know. So here, by default, all um, all subjects are given or are provided with labels. Okay? And in these labels, we can only access the resources with the same label going down. So for example, I am given a label um, top secret. I can access top secret resources going down, secret, confidential, and public. Okay. If person B has a secret label, he can access secret going down, but he cannot access top secret resource. Okay, so that's mandatory access control. So the initially this type of access control when it was implemented, it was meant for government and military use. However, the limitation is that it's quite restrictive. It's not um, flexible for commercial use. Like for example, um, in the academe, if I have say if I would like to get information about a student, if he or she has already passed the course, okay, then I will inquire as a faculty. My label is secret. Okay? And if I inquire that to the registrar might not give that information because the label is student's information's label is top secret. So the registrar cannot give it to me. So, but I need it to determine whether the student can enroll or not. So it's not flexible. That's why a new access control type came. Okay, and this time it's called discretionary access control. So in discretionary access control, the owner can decide the access privileges of the object. Okay? So the owner has full access of the file, and then the owner can decide what access privileges will be given to others. So for example, again, if I'm the registrar, I can say, okay, for the grades, nobody can access, it's top secret. But for the courses taken, it will be um, it can be accessed by this person, by the faculty members. Okay. So in this example, there are um, three um, three subjects. We have Manny, Vanji, and Alfred. And Manny owns file 1, Vanji owns file 2, and Alfred owns file 3. So they have full access. They have read, write, execute access to the file. Okay, so Manny can now determine the access privilege to the other users, Vanji also, and then Alfred. Okay. So aside from the owner who has full access of the file, so again, the answer is the root or the administrator. Okay. Now, um, again, there is a limitation in the implementation of discretionary access control because, let's say, for example, for a certain user, okay, or a certain file owner, he will have to provide privilege for all the subjects, and if the subjects if the number of subjects is very very large, then it will be tedious for him to provide privilege for each one of them. Okay, so for example, I have 100 faculty members, and then I'm the registrar. It's very hard it will be very tedious for me to provide access, the same access to all the faculty members. Okay, that's why a new or another access control type emerged. This time it's called role-based access control. So in role-based access control, the user is assigned a set of roles that he or she may perform. It's also known as non-discretionary. So how does it work? So again, using my example a while ago, I can group now. Let's say I have a faculty group and I can determine the access privileges of the faculty members for each of the files. So for example, for file 1, you have full access, file 2, read write, for file 3, you have no access. And then I'll just add who the users are. So in this case, the users are Manny, Vanji, and Alfred. For the second group, I have the group for the students. Okay, they only have read access for both file 1 and file 2 and no access for file 3. And then I'll just indicate who the users are under the student category. Okay, so it becomes more flexible. So that's role-based access control. Now, the last type is rule-based access control. For rule-based access control, um, it uses objects to help determine whether to grant access or not. So we say that for rule-based, um, this is similar to what or how um, the firewall works. No? So if the firewall rule is permit TCP 80 any, okay, permit TCP 20 and 21 any, okay, which services will be allowed by the firewall? So by default, port 80 is web, port 20 and 21 is FTP. So HTTP and FTP traffic are allowed. And the others will be denied due to implicit deny rule. So that's rule-based access control. So we cannot use it the other way around. We're in, well, port, let's say port 22 should be allowed because there is no rule saying that it should be denied. So it cannot be the other way around. So it has to be explicitly stated in the rule. If it's not stated, then it is understood that it is denied because of the implicit deny rule. Okay. Now, let's go to the types of authentication. Okay, so we'll cover the common types. Okay. So authentication ensures that only valid users are admitted. So what are the some of the types? We have something that you know, something that you have, and something that you are. So when we say something that you know, these are passwords, okay, or something in your head. Okay, something that you have is something tangible like an ATM card, and something that you are is a body part. So it can be a fingerprint, it can be um, your voice, etc. Okay. So According to studies, okay, what is the most accurate biometric? So the answer is a retinal scan. Okay. Now, can you give an example of a multi-factor authentication? So when we say multi-factor, it's a combination of um, these types of authentication. It's either two or three of these, okay, types of authentication. So it's either an ATM card and a PIN. So ATM card is something that you have, and a PIN is something that you know, or a fingerprint and a badge pass. So badge pass is something that you have, fingerprint is something that you are. Okay, and then there are a lot more combinations available. Now let's go to defense in depth. In defense in depth, it says that there should be multiple layers of security before gaining access to the data. So we go to security architecture again. Um, so multiple layers. So it can be um, coming from physical going in. Okay. And then later on, if you focus on physical security, okay, it can be defense in depth still and apply it like you have a gate and then you have a CCTV, you have a guard, etc. before going into the resource. Okay, so now let's go to diversity of defense. Now, in this concept, it says that we should not rely on a single brand of security device. Now, this is very hard for IT teams to defend management because when you when you subscribe to a certain brand and you take one of its packages, it's way cheaper compared to buying each of the components from different brands. And obviously, for management, they're looking at the cost. But we should be able to explain to them the importance of diversity of defense because if we deploy a single brand for the entire infra and there is a vulnerability found for that specific brand, no matter how many devices you have, all of them are vulnerable. And that will make the defense useless. Okay, so that's why it's important for them to realize that and let them weigh in. Probably you can have, for example, in this case, Cisco. You can have five Cisco, um, either firewall or let's say firewall, and then another one would be a different brand like Fortinet. Okay. Another concept is security through obscurity, and this is also common for a lot of organizations. Now, in this security concept, okay, it's the feeling of security by hiding the asset and thinking that nobody else will think the same way. So this is similar to, for example, um, hiding the key to your home underneath the doormat of your front door, okay, or under the um, flower pot. Okay, so you think that nobody else will think the same way, okay? But actually, there's no security there. So to answer the question, is practicing security through obscurity a good security practice? So the answer is no, definitely not. Not a good security practice. So putting $1 million in a locker, thinking that nobody will think that there's a huge money there, gives no security at all, right? Because even if there's an accident that um, suddenly there's an earthquake, um, and then the lockers fell down, and then it opened suddenly, then everybody will have a piece of the $1 million because there's no security at all, right? So that's security through obscurity. And a lot of companies are still observing it, probably indirectly. Okay? So That's not a good security. And then last would be cost benefit analysis. So we will discuss this in detail in another lesson. But here it says that the cost of the safeguard or protection should not be greater than the value of the asset. And this actually sometimes is actually the challenge also for IT security teams because um, coming from a technical group, you would say that this is the best solution for this type of problem. We have to buy an all-in-one security solution, but it's very, very expensive. Okay? And we're just going to protect a single server. So that might not be practical for you to buy. So you have to weigh in and do cost benefit analysis as well. So you can defend to management that we need this, at the same time present a TCO or a total cost of ownership and ROI or return on investment. Okay? Because at the end of the day, we don't want to overspend, okay, for security control. So we have to balance it out. Okay? So again, it's impractical to buy a safeguard that is more expensive than the asset. Okay? Otherwise, the thief might steal the safeguard instead. For example, there's a vault that is worth 30,000 pesos. Okay? And then there's a Rolex, quote unquote, so it's probably fake, that costs 3,000 pesos. So will you put the fake Rolex in the vault that is 30,000 pesos? Obviously, that's a no-brainer. You will not put it there. Right. So that is cost-benefit analysis. So this sums up the Module 1 General Security Concepts for Information Security. So we discussed um, general security concepts like defense in depth, security architecture, security service and mechanisms, the types of access controls, um, types of authentications, types of least privilege, and the least privilege concept itself. And um, we also discussed cost benefit analysis, diversity of defense, and security through obscurity. So, for any questions, you may send me an email or um, type down your questions in the comment section of this video. Thank you very much, and see you on the next lesson.